Welcome to the next video. After I introduced you what Python packages are, I will present you our base structure of our package that we will extend in the following. So as you saw before in the course, we had the vector.py file where I have created a class that implements a 2D vector. And based on that, I want to create with you a Python package that is called FastVector. It's just a name that I have chosen. And I have prepared the code base, as I said here, for the following videos of our package. And at first I have created here a directory that is called FastVector. It is common to name the directory where our source files, so our Python files here in this example, are located, as we want to name the Python package. So I want to name the Python package FastVector, so it is common to name this directory also FastVector. Inside this directory, I have created a dunder init.py file, which will export all classes and possibly some more functions that we have defined in our package here. So for the moment, it's just here from.vector. So here again, it's a relative import vector2d. So if a user now would import from FastVector, he can just use this vector2d class. Also, if the user wants to import with a wildcard import, which is not good practice, as I said before, he would import the vector2d class. So I have just created here this little dunder init.py file, and I have just copied our vector.py file from the previous chapter inside the FastVector directory here. So currently our Python package consists of the dunder init file and the vector file. Furthermore, if you want to have unit tests in your code base, so every good Python package should have unit tests to just make sure your code is correct. So for that, in most cases, you would create a test directory here in the on the same level as our FastVector directory, so in the root directory of our working space. And inside this test directory, you would just create for every class that you want to test, for example, one file. And as I said before in the introduction to unit tests video, these files should be called test underscore and then explicit name what you want to test. So for example here, I have created a file that is called test underscore vector. So this indicates we want to test the vector class here. I have copied here the code from the introduction video of the unit tests, and we will extend our unit tests in the future. For now, we have just these 6 test methods here implemented, but we will continue on completing all possible methods that should be tested from our vector2d class. So as I said, important, I've created here a test directory, and if we run pytest now, pytest would scan in the current working directory for a directory that is called tests. Pytest expects for Python packages that these tests are located in a tests directory. Let me activate the correct Python environment, and for example, I could run here the test vector.py file, for example, and this would work. I could also call here from the command line the pytest command, and this would also run all tests that are found here inside the test directory. So the nice thing about pytest is it just scans our working space here. If it finds a directory that is called tests, then it will scan the directory and would look for files that start with test underscore. In our case, it's currently just one file here. And here we have the similar output to the unit test video. Okay, then next, now the important thing here is the setup.py file. With a setup.py file, you can configure the different attributes of a Python package. So if we want to upload our Python package in the future to PyPI, we should define at least who the author of the package is, what license do we have, what version the package has, and for example, which Python versions are sufficient to run our Python package or to execute our Python package. So the setup.py file is, let's say, the main function of installing or publishing a Python package. And I've prepared the file here so I can go through this. At first, I import here from setup tools, import setup. With this setup function, we will just be able to install our Python package here locally at first. At next, I have defined here some global variables. And to elaborate something, I will go to the PyPI page. So I'm here now on the PyPI page, and this is a Python package index where you would install your Python package with pip, for example. And if I would go to NumPy, for example, we would see here a project description. We would see here the metadata, for example, the license, the author, and which Python version, for example, is required. Furthermore, we see here some classifiers. And if you go here on the release history, you would see the current versions of the Python package here. And all of these attributes that I showed here are set in our setup.py file also. So for example, here I have set the classifiers. So the classifiers are categories to describe what our package is about, or for what operating systems, for example, the package would work. So since we do not have here any special implementations that need some special libraries for an operating system, I could list here all operating systems. For example, also I've just added here the topic as software development, a kind of broad topic. So every Python package counts to software development. So if you have a really specific package, you could list here a specific topic. Also, you could list here what the programming language is about. So it's a Python program, obviously. And we could list here which Python versions are allowed, for example, if we do have any restrictions on the Python version. If you do not have any restrictions on the Python version, unless it's Python 3, for example, you could just list here Python 3. But if you have any restrictions, for example, it must be Python 3.7 or 3.8, you could list it here in the classifiers also. Then the next is the distribution name, or you could also call it package name, which, as I said before, I will call it fast vector. You can call it any name unless it is already taken on PyPI. That would have name conflict, for example, if you want to upload it to PyPI. So you cannot name your own package NumPy, for example, and then expect to upload it to PyPI, for example. Then at next, you could enter here the author and the email of the author, for example, a short description, the license, and a README. So this would be a longer description, for example. All of these are not mandatory. The distribution name is mandatory, for example. So at next, you can define the current version, and this is also mandatory if you want to upload it to PyPI. So the naming syntax of the version is you have at least 3 numbers. The first number is the major version, the second number is the minor version, and the third number is the micro version. So the micro version are bug fixes that do not change or add any new functions to the code. So just bug fixes, for example. The minor version here would be adding new functions without breaking the existing code. If you have developed or updated your code and the new code isn't compatible with the old code, then you would need, or you should, increment the major version here. So if you have breaking changes that will change the whole behavior of your package, you should, for example, here increment your major version by 1. So for example, I would update it here to 1.0.0 then. And if I now would add some functions without breaking changes, you could then update it to 1.1. And if you found a bug in the current implementation, you can fix this bug, and then you could increase the micro version here. Yeah, as you saw here for NumPy, for example, there would be the current version 1.20.0. If you have sometimes not yet released a final version, you can release candidates. So this RC1 here stands for release candidate 1. So these are just pre-releases, and as we will see in GitHub later on, you can set a release as a pre-release. So the current stable version here is 1.19.4, so major version 1, minor version 19, and micro version 4, for example. So I set this here. Then at next, as I said above, you can define if you have any requirements on the Python version. So this parameter will be called Python requires, as you will see below in a moment. You can also list here Python packages that should be installed if you want to install this package here. So for example, if we would use NumPy and SciPy just as an example in our package, so if we would use some of NumPy functions or SciPy functions here inside our vector class, the user have to install NumPy and SciPy if he wants to use our package, okay? And if I list these packages here in install requires, then pip will automatically install NumPy and SciPy if these packages are not yet installed. This is just the information for the package installer, for example, like pip, to install these packages, or that these packages are mandatory for this current package. Furthermore, you can list here where your source code of the package lies. So I have just listed here the folder name, so the folder FastVector. And if you want to upload the tests also to PyPI, you can list here the tests folder. You could also just leave out the tests. That would be okay, but then if the user installs your Python package, so pip will download it from the PyPI server, the test folder won't be downloaded. But this could be okay for your case, You have to think about it when you're creating your own package if you want to distribute this tests folder. Okay, and next here I have created a dictionary that is called metadata, and this metadata dictionary is passed to this setup function that I have here imported in line 2 from setup tools. So if I call the setup function, the whole installing process of the Python package will start. And here I just passed in all the global variables that I have defined here above. Okay, so now is the question, how can I really install this package here? And there are two options. You can either install the package to your Python environment, and you can install your package to the Python environment, but you do not copy this code to your Python environment. You just reference to the current folder where we are. So we are currently here in some folder, for example, on my desktop. And if I'm currently working on my Python package and I just want to update my code and not install it, so I don't want to install a final version to my environment, so I just want to work on a non-final version, then I can use a different command. So the one command would be python setup.py install. Here this command in line 2 would install your final package version, so to say, to your Python environment. So it would just copy this code here, and if you have any C extensions, for example, would compile the code and would place this code and these compiled files inside your Python environment. If you do not want to install this final version, you can just run here the command from line 1, and this would just use the local files that are located here in the current working directory, and these would be referenced to our Python version. So if I type here now, let me at first activate environment. If I would just here run python setup .py develop. Then this current working directory is referenced to our Python environment. So here I would see the path to my Python environment. I could go to there. And here we should see a fastVector.egg-link file. So this is a link to our current working directory. If I would run the install command, then the whole code is copied to our Python environment. So for Anaconda, it is inside the lib site packages folder. Here are all packages moved to or installed that are installed in our Python environment. So for example, if I would install NumPy, here should be then a NumPy folder for the current installed NumPy version, for example. So for really developing on a Python package, I would always recommend to use the first option. If you want to install a final version of your package and to just use it outside the package here in your other projects, you can run the install command, for example. But for the moment, I will leave it here with the develop command. So this is the first basic structure here and the first step how you can run or install the code. So as an example, I could create here a main.py file and import from our package. So from fastVector import vector2d, for example, and I could create here a vector of v1 is equal to vector2d of 1 minus 1. So if I would run this code now, it is working as expected, and that's enough for the moment. We will see us in the next video. Bye bye.